Hello and welcome to this Unity tutorial on coroutines. We are going to use coroutines to implement an invulnerability logic and also some red and white blinking when we get hit by enemies. And then after we got hit for a certain amount of times, we will respawn. A Unity coroutine is an incredibly helpful structure if you want to implement some behavior that should be executed for a limited amount of time. It seems quite magical because it allows you to literally stop execution of a piece of code right in the middle of a function. With this yield return statements, we can stop execution here for the given amount of time. But this is of course not magic, just very clever C# implementation and Unity logic. Coroutines are surprisingly easy to use though, even if they have this magical quality to them, and they will save you a lot of unnecessary timer implementations in your update functions. On a little side note, we will also explore what it means to have a virtual start method and use polymorphy for Unity methods. That of course has nothing to do with coroutines, it's just something that we need to do in order to make this example work. So without further ado, let's start implementing. To be able to change the king's color between red and white, we need access to its sprite renderer in the platformer controller. So here I have added the sprite renderer field, but we need to assign this now, which we of course want to do in the start method. But we have the problem that we already have a start method defined in controller2D. So with our setup, with the controller2D handling the rigid body and then the platformer controller inheriting from it, so we don't have any duplicate logic with our enemy controller, we have the problem that we can only have the start method that Unity will call defined in one of the two classes. So either in controller2D or in platformer controller2D. Unity cannot call both of the start methods. But we can solve that by declaring the start method in the base class virtual and then overriding it in the child class. Note that by default, because we don't have any access modifier here, it would be internal, and internal methods cannot be overridden. So we could as well just make this public. And then in the child class, we will override it. Change the access modifier to public and declare an override. And here we can now assign our sprite renderer. And that's all good, but we already have the next problem that because now Unity would call the start method from platformer controller, the start method from controller wouldn't be called anymore. So we actually have to call that manually, and we do that using the base keyword. So base.start will call the start method from the base class of platformer controller. Then that method will be executed, assign our rigid body, and the child method then will assign our sprite renderer. And since enemy controller does not override start, simply the base method will be called by Unity. We will also need to keep track of our lives, so I will add a new integer field lives here and set that to 5 by default. We are now ready to go to implement the blink red and white logic if we get hurt. And this is a situation where we want to have something happen over a certain time span. And that is something that Unity coroutines are absolutely perfect for. So let's go ahead and define a new coroutine. Here at the end of the class, all coroutines need to have the return type IEnumerator, and I will call this invulnerability. We're gonna give it a certain time that it should be invulnerable. To keep track of whether we are invulnerable or not, let's first define a boolean here. That is by default false. Then in the coroutine, we will set it to true. wait for a certain amount of time. And then set it back to false. There. If you're wondering what the hell this actually means now, so a coroutine is a specific special case of a function. It is a structure that can be stopped from executing in the middle of it and then continue at a later point. So if we call a new coroutine here, or start a new coroutine for the invulnerability, we will start at line 52, execute this line, and then stop at this line for the specified amount of seconds, and afterwards continue the execution. This sounds a little bit like magic at first, but it is possible through a very smart structure of the coroutine running system implemented by Unity. That means that we can also not start this function like a normal function. So we could not simply call invulnerability and then expect it to stop executing here. We have to start it within the coroutine running system of Unity. Before we get to the sprite color changing, I would like to test out the invulnerability. And for this, we need to implement some logic that makes us lose a life if we take some damage, and then turn invulnerable for the certain amount of time. And also while we are invulnerable, we don't want to lose another life if we hit an enemy. For this, I will specify a new function that I call take damage. And this will be called instead of the load scene here in our hurt function. There. Now, if we are invulnerable, we don't want to do anything. We just return, right? Because nothing should happen. Otherwise, we subtract 1 from our lives. Then if our lives are smaller or equal to 0, so if we have run out, we will load the scene again. We died. And otherwise, we have to start our invulnerability coroutine. And this we do as said through the Unity coroutine system. So we have to call the function start coroutine with the invulnerability function. Just going to set this to 1 second for now. And this way, the function invulnerability will be called as Unity coroutine. The coroutine structure that is created will be attached to our game object, and it will run until it ends the function. So it will start, stop at this line, wait for a second, execute the last line, and then enter the exit of the function. And that means the coroutine is finished, and then the whole coroutine running structure will be removed again. Because of our Boolean check here, we will not start another instance of the coroutine if one is already running, since we set this Boolean here to true the first instance when we start the coroutine. So it cannot be started again while it is running. If we wouldn't have done that, we could have actually started multiple instances of this coroutine at the same time. So there is nothing that would prevent you from running the same coroutine multiple times at the same time. So they would just coexist, all the different coroutine instances. To visualize a little bit better what is happening, we can also already put the color of our sprite renderer to red when we got hit, and then put it back to white after we are done being invulnerable. Let's try it out now. Go ahead and jump in front of one of the snakes. There, and we stay red for a few moments, exactly 1 second actually. And also while we stay red, we are invulnerable, so I cannot be hit again. That seems to work very nicely. Now let's go ahead and implement the blinking. For this, we will implement a little loop here inside our coroutine, what we are going to do is change the color to red, wait for a little amount of time, something like 0.1 seconds, change the color to white, then wait again for a short amount of time, and we do all of this inside a for loop. Let's define an index here, starting at 0. Then our exit condition is as long as our index is smaller than the time divided by our 0.2 second steps, right? 2 times 0.1 second, that is the length of each step. And then we increment and move, of course, all of our logic into the for loop. So it doesn't matter where these return statements are, as long as they're inside a coroutine in a for loop or outside or wherever, we will wait at this specific line of code for the specified amount of time. Let's try this out now. For this, I will go ahead and just maybe make some room here and then jump in front of one of the snakes. Great. So there I go and blink if I get hit, and if I get hit 5 times, I will restart. And also, while I'm being hit, right, I cannot be hit again as long as I'm blinking. There is a small problem with this implementation, and that is that if I go and stay here, continuously colliding with the snake, I won't actually trigger a new hurt event. This is because we have based our collision logic on collision enter, and this will not be called if the collision persists over multiple frames, only when the collision starts. So as long as the two objects would keep colliding, we don't get new hurt functions here. And thus we do not check again if we should start the invulnerability and lose any lives. We have to change this to on collision stay to account for the fact that we could actually, while we are invulnerable, keep colliding with the snake, and then once the invulnerability stops, we should check again if we get hurt. This works great, but it is a little bit problematic for the snakes now, because on the collision they will invert their direction. So while they are colliding, they will just actually keep flipping back and forth. So we have to improve the directional logic of the snakes also a little bit now to account for the continued collision detection. And that is luckily quite easy. All that we have to do is, instead of simply flipping the direction, we have to take the sign of the impact direction horizontally and assign that to direction, and actually the negative impact direction that would be, because we want to walk away from whatever we impacted with. We also have to cast this to an integer because our direction is an integer value. There we go. Now we have robust snakes and also robust invulnerability logic, or at least a bit more robust. It's always good to keep in mind that our controller here is still quite simple, and to make an actually super robust and good implemented controller takes a lot longer and has to account for a lot more special scenarios. To sum up, we learned that coroutines are a great way to implement behavior that is to be executed for a limited amount of time. So we have implemented invulnerability logic to get a certain amount of invulnerability frames while we cannot be hit again, and also to blink the king red and white to give some user feedback for when we are hit. We also upgraded our collision logic a little bit to account for the fact that we now have a situation where we would collide multiple frames with the same object while we are invulnerable and have to check again after the invulnerability expires. And we concluded that it is quite difficult to make a robust platformer controller. It takes a lot longer than we have time for in these tutorials, but you have now another tool in your repertoire to make that happen.